first and second hour. I'm missing you today. I'm out at an instructional coaching conference today. Sorry that I missed you, but I wanted to make sure to let you know that we have a very important day ahead of us. This is the first day that we're in Enthrot Canopy, so I wanted to walk you through that process as if I was there. So here's a video for you to walk you through that. So the first thing I want you to do is actually pull up Canopy. By doing so, you can hit the Windows key on your keyboard and then type in the word Canopy and then open that program. That should come up. If it doesn't come up, it's actually located in your student programs folder that you guys access sometimes to open up some programs. So open that up. When you open up Canopy for the first time, it'll load. And then you'll see this screen. Once you're at this screen, I want you to hit this editor window, and this is where we're going to work primarily. So when you're here, you'll see a few different windows. You'll notice this window up at the top. That's the code editor window. Down here is the IPython session, and here are your common files. Right here in this code editor window, this is where we're going to write our programs, and this is where we're actually going to run our programs for a large part. Essentially, what Canopy is it's a code editor and a compiler in one, so that you can edit it up here, run it, and then use it down here as needed. And when you're here, if you select create a new file, we get an untitled file and a tab that shows up. We can go ahead and we can create another new one. Again, we have tab sessions. One little thing that's not in the document, you can create a new pane on the right, so you can take a look at two different pieces of code and that winds up being really helpful as we need to do it, to compare and contrast different pieces of code that we're working on. Now, everything I do in this session right now in this video is going to be a little bit of what you're going to be doing during class today, but I wanted to walk you through it so you see it. One of the reasons why Canopy is really powerful and Python's really powerful is that we can draw from a whole set of libraries or modules, and those libraries or modules are big giant blocks of code, files of code that have predefined functions and kind of functions and activities and methods and things that can calculate some things. So I'm going to show you the first one. This one in particular is called matplotlib. So to do this, I'm going to type in the editor window. I'm going to do import matplotlib.py plot as plt. And we hit enter. So essentially what I just said to the computer is I said in the IPython session, in this program that's running right now, draw on all of this information from that file matplotlib, and we're actually going to bring it in. We're going to give it a shortcut name, plt, so it's easier to write. So now what I'm going to do is I'm going to use a built-in function in Python. It's the random function based off of the normal distribution, or a standard normal curve. We're going to give it choose from 10,000, run it 10,000 different times. So I'm going to hit enter, and that's going to take it and specify what A is. And then if I turn around and I type in A and hit enter, it's actually going to show us all the different numbers that end up getting specified for within this list that was created from this random number generator that's related to the normal curve. So essentially we said grab 10,000 numbers or 100,000 numbers from the normal distribution curve, store it in this list A, and then when I hit enter, it showed it back as an array. We'll talk about what an array is a little bit later. But essentially what we're going to do is we're going to use matplotlib now. If we do plt.hist, that's a function that's in plt, which is matplotlib, and it's going to show us a histogram. It's going to create a histogram, and it popped up. If you notice, we have a histogram of those numbers that are represented by the array that we've called A. We can do the same thing. If we do plt.show, that'll help us show it as well. But in this case, it had already shown up. There it is. Whoa! So the magic of computers is I just popped up this other window, and this window references variable roles. So A was a variable in Python. Now A didn't necessarily have a role in what we just did. And we're going to talk about the difference between variable types and variable roles. In this case, this slide shows the varying variable roles that we've talked about previously and had a conversation about. But then what we're really going to talk about today and in a little bit when we deal with Canopy and Python is that variable types. So a variable could have a role, but it also has a type. Now Python's smart enough to decide what type of variable role has based off of the kind of data that you store in it, which is different than Java. Java, you have to specify the type as you're using it. Some of the variable types that we're going to use in this unit are ints, strings, lists, and tuples. Lists and tuples do very, very similar things. They're also very, very similar to what we call arrays that showed up in the last thing. So we're going to talk about those. We also talk about floating point numbers, long numbers, which references just a really long number. But again, ints being integers, floats being decimals, strings being words. One of the key variable roles that we want to talk about in Python is a fixed variable role. Convention says when we're using a fixed variable, we actually specify it with all caps. We specify the name of that variable if it's going to be a fixed variable with all caps, so that when it's buried in all the lines in code, we see this word that represents what the variable is, or the context of the variable. And since it's in all caps, we know that that variable is a very specified number that's likely specified towards the top of the code itself, or towards the top of a function that is created somewhere in the code. Some of the other things I want to get you to pay attention to is when we're talking about accumulators. In Python, we can use some shortcuts. Instead of saying that A equals A plus 1, we could say that A plus equals 1. Now let me clarify that in the Python editor. If I have a variable B and I want to say that that's 5, right? And then I want to actually if I want to add, take B and add 1 to it, and then turn around and assign it back to B. So essentially what I'm doing is it's going to make it 6, but I want to take the value that B currently is, which right now is 5, I want to add 1 to it and put it in the spot for B. So if I do this and then I type in, it's going to just do its work, and I type in B again, now it's going to say that it's actually 6. If I start that over and I start B being 5 and I want it to be 6, and I want to just add 1 to it, I can do a little shorthand coding here that says B plus equals 1, which again will make B back to 6. Okay. The same thing is true with times. If I do B times equals 2, now it's going to take 6, B times 2, and then store it back into B. So it's going to be 6 times 2, which is 12, and then it's going to make B equivalent to 12. So again, if we do this and we type in B, now it's going to be 12. So I think that's enough video for you today. What I want to do is stop it here, and we will catch back up on Wednesday when I get back to school, and see you then. Again, make sure you work through the document and crank it out and have some fun messing with the editor, the code editor, and the IPython session. I can deal with any misinterpretations of what to do, what the different parts are, how to manipulate it when I get back. Thanks, and have a fantastic day. Peace.